This is Dr. Shoykot Majumdar. Under Basic Physics course of Diploma Engineering, we will discuss transmission of heat. This is under Unit 3 of Heat and Thermodynamics. Learning objective is to understand different modes of heat transmission, thermal conductivity, good conductor, insulator, and their use in daily life. Now, let us discuss the heat transfer. There are actually three modes of transfer of heat. Number 1, conduction. Number 2, convection. Number 3, radiation. Now, when the energy is transferred by direct contact, this is conduction. Suppose a pan is heating on the oven. Now the handle of this pan becomes hot. This is conduction. Suppose the iron rod is heated red hot, then one end is heated, other end becomes hot. That means heat is transferred from one point to another point without transferring the molecules or particles. This is the conduction. Next part is convection. Energy is transferred by the mass motion of the molecules. Here in this pan, say water is being heated. Now, initially at the bottom surface, heat is supplied to this one. Now this becomes lighter. Now these particles will move upward and the heavier particles will come down. This is how there is a cycle. Lighter particles getting heat will move up, heavier particles move down. This is how the entire water becomes heated. Similarly, in weather system also, air close to our surface becomes hot, getting the sunlight close to the earth's surface, so it becomes lighter and moves up, and the heavier, to fill up the gap, the heavier air molecules come down, or air movement will start from upper surface to the lower surface. This is the convection. Third one is radiation. Energy is transferred by electromagnetic radiation. Suppose the light coming from sun to the earth, it needs no medium. There is no requirement of medium to transfer light from sun to the earth. Again, suppose something is burnt, then the heat coming out from this one, this burnt position, burnt material to our body, or we get the feeling of heat. This is when we are outside or we are far apart from this burning object. This phenomenon is a radiation. That means energy is transferred from the burning material to the different parts of the ambience or maybe our body. This is a radiation. although we are not in contact with the burning object. Thermal energy transfer is heat moving from a warmer object to a cooler object. Suppose this is the pan where soup is heated in the pan by convection. The hot soup rises and the cool soup falls to take the hot soup's place. This is heated, hot soup rises, cool soup comes down or falls to take the hot soup's place. So this is the convection. Heat energy from the stove to the pan. From the stove to the pan, it is transferred by conduction, direct contact. Pan handle is an insulator. This is the insulator and does not conduct heat very well. How is heat transferred? There are three ways heat can move. Already I have discussed. Number one, conduction, then convection, then radiation. So when the object is burning, say this iron rod is heated, then this part being red heat, hot red, and this end becomes heated. This is a conduction, although it is far apart from this one. The molecules are not moving, but the heat is transmitted through the molecules. Now, what is convection? Convection means the heat is the air that is close to this burning object becomes hot and moving upward, and the cool air is coming down. This is a convection, and the heat produced by it we are feeling from a distance. It is a radiation, although we are not in contact with this one. This is radiation. Conduction, heat is transferred from one particle of matter to another in an object. This is like this. This is the frying pan, food is there. This is the metal plate. Heat is given from the burner. The atoms becomes hot. It is transferring heat, also transferring to the food. Conduction needs contact. Have you ever touched a metal spoon sitting in a pan of boiling water, only to be surprised by how hot is it? Example of conduction. A piece of cheese melts as heat is transferred from the meat to the cheese. That means these two are in contact. That's why the cheese melts. Convection. Convection is the movement that transfers heat within fluids. Fluid means anything that flows. Heat is transferred by currents within the fluid or gas. So this fluid or liquid is heated using this burner. So close to this burner, the liquid becomes hot, it becomes lighter, it moves up, and the cool liquid comes down. So there is a convection current. Have you ever noticed that the air on the second floor of your house is warmer than the first floor? The air close to the surface of the earth becomes hot, and this air becomes lighter, it will move up, and the heavier cold air or cool air will come down to the nearest surface to fill up the gap. So that's why the second floor becomes hot and the ground floor becomes cold. Same thing happens also here for this pen. Convection currents cause the cooler breeze you experience by a large body of water. This is the air becomes hot here close to the surface. It will move up, and this cool heavier air will come down. So there is a cooler breeze. The currents also cause the movement of magma within the earth. This is the movement of magma within the earth. Radiation. Radiation is the transfer of energy by waves. Radiation, its type is electromagnetic in nature. Radiation does not require matter to transfer thermal energy. The light is coming from sun to the earth. Already I have discussed. It is the example of radiation. Radiation may come from other sources also. Have you ever sat too close to a campfire? You are enjoying the warmth only to notice that your skin is really warm. Examples of radiation: fire. This is a huge fire, and the warmth is filled by the people near it. Heat lamps. Say food is used to heat using these heat lamps. Sun. The light is coming from sun to earth by the mode of radiation. Now let us start thermal conductivity. Let us consider a rectangular slab of a substance whose two opposite temperatures T1 and T2. T2 is greater than T1. Let area of each phase is A and D be the separation between the phases under consideration. So this is the hot body. Its temperature is T2, and this one is the cooler part. Its temperature is T1. Its area is A, and these two are separated by a distance D. Here T2 is greater than T1. So heat will transfer from hot part to the cold part. In steady state, if Q be the amount of heat which flows through the slab perpendicular to the phases under consideration in time T. So Q, this transfer of heat, that is the amount of heat, is directly proportional to the area, cross-sectional area, and also directly proportional to the temperature difference, that is T2 minus T1, and inversely proportional to the separation between two faces, that is D. So Q is inversely proportional to D, that means Q proportional to 1 by D. Also the time, more the time, more heat will be transferred. So Q is directly proportional to time. Thus we can write Q is equal to K A T2 minus T1 by D into T, where K is the proportionality constant and known as thermal conductivity, whose value depends upon the nature of the substance. The term T2 minus T1 by D is called temperature gradient. Thus, we can say, to summarize, the heat transferred, that is denoted by Q, is equal to Ka T2 minus T1 by D into T, where K is the thermal conductivity, T2 minus T1 by D is the temperature gradient. The definition of thermal conductivity. It is defined as the amount of heat per unit time per unit area that can be conducted through a plate of unit thickness of a given material. The faces of the plate differing by 1 unit of temperature. Let us come to this formula. K is equal to QD by A T2 minus T1 into T. If the separation between two faces is 1 centimeter, cross-sectional area is 1 centimeter square, temperature difference is 1 degree, and time is 1 second, then K is equal to Q. So we can say thermal conductivity means the amount of heat per unit cross-sectional area that can be conducted through a plate of thickness, unit thickness, and the temperature difference between the faces is 1 unit, and the time is 1 second. That means heat conducted per unit time with the conditions thickness is unit, heat conducted per unit time with the condition thickness is 1 unit, cross-sectional area 1 unit, temperature difference between the faces is also 1 unit. This is the thermal conductivity. Now its dimension. So from this formula, K is equal to QD by A T2 minus T1 into T, the dimension of heat is energy. That means ml square T to the power minus 2. And D its dimension is L. Area its dimension is L square. Temperature difference is theta. And time is T. So K its dimension becomes ml T to the power minus 3, theta to the power minus 1. This is the dimension of thermal conductivity. Now come to the unit of thermal conductivity. In SI system, the unit of K is, from the formula, K is equal to QD by A T2 minus T1 into T, small t. So Q, its unit is joule, D, its unit is meter, area, its unit is meter square. T2 minus T1, its unit is in Kelvin, and time in second. So we can write this one is as joule meter to the power minus 1 second inverse Kelvin to the power minus 1. Now joule per second means watt. So we can write watt meter to the power minus 1 Kelvin to the power minus 1. Thus the unit becomes watt per meter Kelvin. Watt per meter Kelvin in SI system. In CGS system, the unit will be in the same process. This becomes calorie, second inverse, centimeter inverse, and degree centigrade inverse. Calorie, we can write calorie, centimeter inverse, second inverse, degree centigrade inverse.